Okay, so what we're going to do today is a little bit different. We're going to have a go at doing a practical lesson. I don't know how this is going to go, but we're gonna give it a go. Obviously, you can't carry out a practical where you are at the moment, but I've got some equipment here. I'm going to do the practical. I'm going to let you take some measurements, and then we can plot a graph and draw some conclusions from that. Okay, so we'll start by looking at this circuit. Now, we haven't talked about many circuits so far, so I'm going to introduce each of these components to you, and then we'll talk about what each one is doing. So to start with, we have our cell. Now, our cell would be this. This would be a cell. What we usually would call a battery. In physics, we're going to call it a cell. If we have more than one of these, then it's going to become a battery. Okay, so this is our cell. Okay, next we have an ammeter. Okay, and an ammeter is going to measure current. Now we need to make sure whenever we're using an ammeter, it's in the circuit itself. Okay, ammeter must always be in the circuit itself. We call that in series. Then down here we have our test resistor. This is the resistor we're going to be making measurements around. This is our test resistor. Then across our test resistor we have a voltmeter that's going to measure our voltage. So this is a voltmeter. Now voltmeters are always placed across components, okay? Then we've got our variable resistor. Okay, and what that's going to do is that's going to allow us to vary the current in the circuit, okay? And really this is just a resistor that we can change the value of the resistance, and I'll show you that in a minute. Now I should say in my house I don't have a voltmeter and I don't have an ammeter, but I do have what we call multimeters. So I've got two of these, and I'm going to set these to either measure voltage or measure current. Now this experiment we're looking at Ohm's law, and so we've already spoke about that Ohm's law is V equals IR. So if we write that as a formula, it's V equals IR, or we could say the voltage or the potential difference is directly proportional to the current through a component, provided the temperature remains constant. But we can summarise as V equals IR. Now we're going to do some rearranging of this, and we're going to compare to y equals mx plus c, so that we know what we're trying to achieve in this experiment. So we've got V equals IR, so it's going to be the easiest rearranging you've ever had to do. We're going to rearrange so that V equals Ri. Pretty straightforward. And then we're going to compare that. We're going to compare this to y equals mx plus c, the equation of a straight line. And what we'll see here, that if we plot a graph of voltage on our y-axis and current on our x-axis, our gradient is going to give us the resistance. And that's what we're going to try and find out in this experiment. We're going to use two different test resistors, and we're going to try and find the resistance using a graphical method, using Ohm's law, and then we're going to calculate the gradient to find the resistance. Okay, let's have a go at that now. Okay, so this is the setup for the experiment, and it's the exact same as the circuit diagram I showed you. This is going to be our cell. Now we're actually going to use two cells here, so this is a battery. Here we have our ammeter, so really it's a multimeter, but we're going to use it as an ammeter. It's going to be measuring in amps. This is going to be our test resistor here, and we're going to start with resistor A. And then this is what we're going to use as our variable resistor, because I don't have one to hand at the moment. We're also going to need to put in our voltmeter, so that's what this is going to be. This is going to be our voltmeter. And I'm going to put that in across our resistor like that. And move these wires so you can see what's happening. And that is going to be measuring in volts. Now in your booklets, there's already a table drawn for this experiment. You've got resistor A at the top and resistor B at the bottom. I'd like you to fill in the measurements in that table. Now I'm going to change the variable resistor quite quickly. So you might need to pause the video to get your readings. Okay, so let's start now. Let's see what happens. Remember, you're measuring current here and you're measuring voltage here. Okay, so let's start taking our readings. Okay, so I've done more than 7 readings there. I want you to pick 7, put them in the table, and then we're going to move on to the second resistor. Okay, and now resistor B. Okay, let's take a set of readings. Again, I'm going to take more than 7 readings, so you can just pick 7 out of there, and those are the ones you're going to add to the table. So here we go. Okay, so hopefully you've got a full set of results now, and your tables are filled in on page 5. On the next page, there is some graph paper. I'd like you to draw a graph, one single graph that has both resistors on it. Can you work in pencil so you can correct any mistakes you make? Then the next thing you're going to do is you're going to draw a line of best fit for each resistor. You're going to calculate a gradient for each resistor. And finally, you're going to complete page 7, which is related to this practical. And then page 8 is an extra exercise that I'd like you to do. If you don't get that done in this lesson, it will be set for homework. Once you have your graph drawn, I'd like you to take a picture of it and send it to me. And can you also send me your values for your gradients down below it? Thank you.